Next, combination of resistors in series. So let's take resistor. What is meant by resistor? Resistor is a device which opposes the flow of electric current. Okay, let's consider two resistors or having resistance R1 and R2. So these two are going to be connected to the battery. It's a cell. Let's treat it as battery. With the key it is connected. Okay, now key is closed, so circuit is closed circuit, current will pass through it. So this is the direction of current which is about to pass. Here voltage is V. So same current. So what the current is passing here, same amount of current, here is also same amount of current will be passes. Okay, so you can treat that as I1 or I2. Okay, at this point the current is I1, and in this case current is I2. Okay, right. Next, here which is constant? For example, let's take this two as two pipes. This is one pipe and this is one pipe. Both are connected side to side. If you'll pour 1 liter of water here, same 1 liter of water will comes, right or not? That is called series connection. So in series connection, which is constant? Current is constant. What is our current here? Okay, when you pour 1 liter of water, say 1 liter of water current. So here how much water passes? 1 liter. Here how much water passes? 1 liter. That means if you will give current I, here is also amount of current I, here is also amount of current I. Okay, so in series combination, resistance R1, R2, but current is same. Here current and here current is same. Okay, whatever the current is passing here, same current is passing. But what about the potential? Here let's consider this is a big pipe, here is a small pipe. So it can allows more potential, it can allows less potential, right? That means here potential is V1, here potential is V2 as the potential is differing. Okay. So according to the Ohm's law, whatever the potential is there, the total will be equal to these two. That means total potential V equal to V1 plus V2, and total current I equal to I1 equal to I2, right now. Then you know the according to Ohm's law, V1 equal to I1 R1. So it will be simply written as I R1. V2 equal to I2 R2, that simply will be written as I R2. Okay, got it. Then total potential V equal to total current into total resistance. That resistance is series connection. Okay, so in this substitute this V1, V2 in this one. So you will get I Rs equal to I R1 plus I R2. So I gets cancelled. Then R is equal to R1 plus R2. This is for two resistors. If I'll connect one more resistor, then R is equal to R1 plus R2 plus R3. If I'll connect one more, then plus R4. Like this, if I'll connect n resistors, all are identical, then R is equal to n into R. Okay, or S equal to n into R. This is for n identical resistors. Okay, clear? Now see here, V equal to V1 plus V2 plus and so on. Okay, got it? Then here ratio is V is nothing but for V the resistance is RS. So what is the ratio? R1 is to R2 is to R3. That's the ratio of resistances. Then what about current? Ratio of the current? Current ratio is 1 is to 1 is to 1, as the total current remains same. Okay, got it? Now I want to tell you one more point here. That is, in case I came now, just a second. Okay, so Rs equal to NR and Rs equal to for 2 R1 plus R2. Now let's consider here one resistance, here one resistance. This is 2 ohm, this is 1 ohm. So what is the total resistance? 2 ohm plus 1 ohm. That means it is 3 ohm. This 3 ohm is greater than 2, right? So the resultant resistance or effective resistance in series combination is greater than the individual resistances. Okay, the sum of effective resistance, final effective resistance is greater than the individual high resistance or maximum resistance. Okay, in case if you will take this is 1000 ohms and it is 1 ohm, then the effective resistance will be 1001 ohm. That means the effective resistance is greater than this maximum of 1000 ohms. Okay, clear? This is about simple series connection. Let's see some problems on it. So I have two resistors. Let's take two. After that we'll do for three more. Now it is connected to a battery and the connection is like this. Let's consider this is some 8 volts. Here it is 2 ohms and here it is 6 ohms. What is the total resistance? Total resistance is R1 plus R2. R1 is how much? 2 plus R2 is 6. So 6 plus 2, 8 ohms, right? So from this Rs equal to 8 ohms, right? Right. Now how much current is passing here? V equal to IR. What is the total voltage? 8. What is the total current? I. What is the total resistance? 8. So 8 gets cancelled. I equal to 1 ampere. Right. Then how much potential is here? How much potential is here? From this point, the potential is V1 equal to I R1. Okay. So what is the V1? Don't know. What is the current I? I is 2. And what is the resistance R1? 2. Is I is sorry. I is how much? 1 ampere. Current is 1. So resistance is 2. So V1 equal to 2 volts. V1 equal to 2 volts. What about V2? V2 equal to I R2. V2 don't know. I is same one. R2 is 6. So V2 equal to 6 volts. If you add this V1 and V2, we should get this 8. So 6 plus 2, 8. So answer is correct. Okay. Let's see the another one. So three resistors of are connected to here. Here it is 1 ohm, 2 ohm, 3 ohm. What is the effective resistance? Effective resistance will be 1 plus 2 plus 3. So it is 6 ohms. Okay. Now here some amount of current is passing. So let's consider that current is 5 amperes. 5 amperes of current is passing. Okay. Or mm, okay, let it be 5 amperes of current is passing. So what will be the potential here and what is the individual potentials? So total potential is V equal to IR. V is how much? Don't know. What is the total current? 5 amperes. What is the resistance? 6. Then it is 5, 6, 30 volts. So what is the potential here? 30 volts. Then how much will be at 1 ohm? How much it will be at 2 ohm? 3 ohm. At 1 ohm, same formula. V equal to IR. Potential I don't know. Current is how much current is passing? 5 amperes. All the three resistors current is same as the connection is series connection. And resistance is how much? 1 ohm. So V equal to 5 volts. Then at 2 ohms, across 2 ohms, same V equal to IR. Potential is V, current is 5, resistance is 2. Then V equal to 10 volts. Then across 3 ohms, same again V equal to IR. V equal to I is 5 into resistance is 3. Then V equal to 15 volts. 15 plus 10 plus 5. So total is 30 volts. Okay, clear?